Hey guys, welcome to lesson 4.4. Today we're going to continue on with similarity and scale factors. We're going to be building on these concepts a lot and pretty heavily for a while still, so we'll continue to get more familiar with them. I do have a warm-up here for us just to practice dilating shapes based on a scale factor on a graph. So for that question, just remember that the first step is to identify all of the coordinate points, right? So for this point right over here, because from 0 we went right to up 3, this coordinate point is 2, 3, right? Because it was right to up 3. We have another point right over here, which is right 3 boxes, up 1 box. So that point is going to be 3, 1. Right, and I guess I should be writing those as we go. All right, and next we have this point right over here. This is right 2, down 2, so that tells us that our point is going to be positive 2, negative 2. Next up, we have this guy right here. It went right 1 and then didn't move up or down anywhere. So that point is going to be 1, 0. That 0 comes from the fact that it didn't move up or down anywhere. And we have one final point. Let's pick a color for that. Let's do this one. So for this point, we are right 1, up 2. So this is going to be 1, 2. All right, now that we have gone through and figured out all of the coordinate points, remember that is step 1. Step 2 is just to multiply all of these points by 2, right? We would take this one, multiply it by 2, all the numbers, to get a new point of 2 times 2 is 4, 3 times 2 is 6, all right? And then we'll do that for every single point. Times 2, we get 6, 2. All right, and I'm going to pause the recording and get that done so you don't have to watch me do it. Save us some time. All right, I have finished multiplying all my points by 2 because that's my zoom factor. And so now I can go ahead and plot the new points. These 5 new points, I'm going to do that in yellow. And that's going to give me the vertices of my new dilated shape. So 4, 6, we'll go right 4, up 6. 6, 2 is going to be right 6. Up 2, and then 4, negative 4, right 4, down 4, right 2, up and down 0, so this will be right here, and then 2, 4 is going to be right 2, up 4. All right, these are the vertices of my new shape, so it's going to look something like this. All right, so you can see that that's just an enlarged version of the original. All right, and that's how you do these dilations on a graph. Alrighty, moving on to some more specific similarity stuff. If we look at these two triangles, okay, this smaller one is the original, and then the bigger one is a dilation. The side length of this triangle is what we're looking for here first. So side AC, that's going to be right here. That's going to be 1, 2, 3 boxes. So this has a length of 3. BC has a length of 1, 2, 3, 4 boxes, so this is 4. And then AB is one that we don't know, and we can't count boxes for diagonal lines, right? We can only do that for straight up and down or left and right lines. So we actually have learned a way, though, to find the third side of a right triangle. Okay, and that was our good friend Pythagorean theorem. We can go ahead and set up our a squared plus b squared equals c squared. Okay, and the first thing we need to do, though, is label our side with C and then also A and B. This side AB is going to be C since it's the longest, it's the hypotenuse. These two are going to be A and B. Okay, and we know that this is 3, this is 4. So we're ready to plug into our formula. Instead of A squared, we'll write 3 squared. Instead of B squared, we'll write 4 squared. And C is the one you're looking for, so we'll leave that one C squared. Right, once we have this, we can go ahead and square what can be squared. So 3 squared is 9, 4 squared is 16. and just continue to simplify. So like 9 plus 16 is 25. And this is where we end up. Okay, and remember the last step that I told you will always happen in a Pythagorean theorem problem, which is to square root both sides. All right, once you do that, you find out that C is equal to 5. So we're going to put a 5 here. All right, so now that we've done that, we can move on to the bigger triangle. Okay, this is the one we're asking for side lengths for this time, A prime, C prime. So this one right over here has 1, 2, 3, 4, 5, 6 boxes. B prime, C prime has 1, 2, 3, 4, 5, 6, 7, 8 boxes. And for A prime, B prime, we can do the same exact thing we did here and do the Pythagorean theorem, right? We know that this side would be C, this side would be A, this side would be B. We definitely can set up our 6 squared plus 8 squared equals C squared process and solve that way. If we do that, we would get 36 plus 64 equals C squared. 100 equals C squared. We're just adding these together. And that tells us that C is going to have a length of 10. All right. So here's the deal with that. Now we did that the long way, right? But because the bigger triangle is actually a dilation of the smaller one, there is a scale factor that we can use to figure those pieces of information out more quickly, right? To get from this one, with had a side of 3 to 6, we multiplied by 2, right? To get from 4 to 8, we multiplied by 2. Sure enough, to get from 5 to 10, we also multiplied by 2. And that is how we know that triangle A prime, B prime, C prime is twice as big as triangle ABC, right? Because the scale factor was 2. And you could have found that by doing 6 divided by 3 equals 2, or 8 divided by 4 equals 2, or 10 divided by 5 equals 2. Okay, they should all equal the same thing, as long as you match the sides correctly. All right, the point of dilation, our point of dilation by default is always going to be the origin. We can do dilations around other points, but for the sake of simplicity, we're not going to do that, kind of like how we also only did rotations around the origin. We're not going to complicate it further than that. And part D is asking if multiplying each side is equivalent to adding the same amount each side. Okay, so that if we think about that, if we added 1, or let's say 2, if we added 2 to this side, that was 3, and we also added 2 to this side, that was 4, right, we would not end up with the same answer, right? It would not end up the same at all. We would end up with 5 and 6, and that would not be proportional, okay? Adding does not have the same charm as multiplication. Okay, so adding does not maintain the proportions. Okay, the picture would be all wonky if we did that. It all works by ratios. All right, so here's another little example. If we took triangle ABC and dilated it again to find A double prime, B double prime, C double prime, right? And now A double prime, B double prime is 20 units long. Okay, how many times bigger is the new triangle from triangle ABC? Okay, this is called zoom factor, which is the same thing as scale factor. Now, if we look up at our original AB, it was 5. And the new one is 20. Okay, so to figure out what the scale factor or zoom factor is in this case, we would just do the new divided by the original. That's always how you find scale factor here. So 20 divided by 5, and that gives us a zoom factor of 4. All right, so again, it's always the new divided by the original. Okay, let's do another example. For this puppy's head, right, we have the original that had a height, his head had a height of 5 units, and the bigger version had a height of 15 units. So again, new divided by original. So 15 divided by 5, that gives us a scale factor or zoom factor of 3. Recall when we were doing transformations at the very beginning of the semester, right? We did reflections, rotations, translations, and please remember that those didn't change the size of the shape, right? Only dilations change the size. That's the only transformation that will change the size of your shape. Alrighty, we have one last thing to do here, and this is just an example of dilating a shape on just a blank grid. We don't care about the coordinate points in this case. We're just gonna make our shape based on the zoom factor, which means really we're just paying attention to the side lengths, okay? So the first thing I want to pay attention to, and I want you guys to understand, is what happens when we dilate a shape by a scale factor of 1. Okay, that's the first thing they want us to do. If we multiply all the side lengths by 1, well, what do we think would happen, right? Anytime we multiply something by 1, the answer is just itself. So I know that this side, for example, this side has 1, 2, 3, 4, 5, 6, 7, 8. This has a length of 8. If we did 8 times 1, the new one would still have a side length of 8. So that tells us that anytime we dilate by a factor of 1, our shape stays exactly the same. Okay, so really I would just draw a figure with the exact dimensions as this one on my grid. So this has a side length of 6 boxes. Sorry, that is pretty ugly. I'll draw a new line. Slightly better. Okay. This one also has 6. These 3 are all side lengths of 4 boxes. And these 2 are side lengths of 2. So I'm just going to draw that exact one because it told us to do the dilation by a factor of 1. So I have 1, 2, 3, 4, 5, 6, 7, 8. And then I had 6 up here. 2, 4, 4, 4, 2, and 6. There's my original. All right. Next up, we are going to do a dilation by a factor of 2. So anytime we dilate by a number greater than 1, that's a greater than sign, our shape is going to get bigger. And in this case, it's going to be double. So instead of 8, it's going to turn into 16, because 8 times 2 is 16, right? Instead of 6, it's going to turn into 12. Instead of 2, it's going to turn into 4. All these 4s are going to turn into 8. Okay, we're just multiplying everything by 2. And we'll go ahead and draw our new shape with those new dimensions. So I'll just start at the same corner, because it's a little easier like that, just so we can see all of them compared. All right, I just went a whole length of 16 there. Next I'm going to go 12. Next I'll go 4. Oop. I'm just following these green numbers. Another 4. Oh, nope, just kidding. This one's 8. We have another 8. One more 8. A 4. And lastly, we have 12 down here. Okay, so this shape is twice the size of the original because we did a zoom factor of 2. All right, the last one we're going to do is a zoom factor of 1/2. I am running out of time for recording here, so I'm going to pause the recording for a second and figure out the new lengths. All right, as you can see, I took every side length and just multiplied it by 1/2, which you can also just do 0.5. That just cuts it in half, right? And then we're going to make our new shape with new dimensions. So I'm going to do that real quick. And that's my new shape that's half the size of the original.